Laws of chemical combination. See, elements they combine to form molecules, right? For example, two hydrogen atoms can combine to form water molecule along with oxygen. So two hydrogen plus one oxygen gives what? A molecule of water. Similarly, how the methane molecule is developed, four atoms of hydrogen combined with one carbon to form CH4. Okay, right. But how these atoms are combined, how these molecules are developed, how these reactions are possible. So all these are governed by the law of conservation of mass. That is a very, very important. So according to the Anthony Lavoisier in I think 1789, he said the matter can neither be created nor be destroyed. You cannot create. Can you create any matter? Have you ever created any matter? You cannot. You are just converting matter from one form to another form. So what we are doing is only conversion. Like energy, matter is also conserved. Okay. So what is law of conservation of mass? Take down. Law of conservation of mass. Matter can never be created. And you cannot say I have completely destroyed the matter. It's possible. It's not possible. So destroy, not possible. So the matter can neither be created nor be destroyed. But it can be converted from one form to another form. One form to another form. Conversion is possible. It means matter is convertible, but matter is indestructible. It cannot be created, right? Now, this law is called the law of indestructibility. Destruction means destroying completely. So, destructibility means it cannot be destroyed. So, in all physical and chemical changes, the total mass of the reactants should be equal to the total mass of the product. Then only you can say it is conserved. And based on that only, we arrived at that mass ratio, stoichiometric problems, etc. Got it? So you can make a note of it, take down in all physical and chemical changes. So the same law of conservation of mass can also be interpreted in terms of what? Reaction, a chemical equation. When you say chemical equation, it involves products and reactants. So reactants on the left side, products on the right side. You have got one reactant and that is attacked by one reagent so that you are able to get a product and byproduct, right? So let me consider A reacts with B to give C plus D. So these are reactants and these are products. So the mass of A plus the mass of B should be equal to the mass of C plus the mass of D, right? And it can be simply because since we have only two reactants and two products, I can simply write Ma plus Mb is equal to Mc plus Md. But in case of n number of molecules involved or n number of reagents or reactants involved and products, so in that case you can put the sum of summation. This is called summation. The sum of what? Reactants, the moles of reactants you can say is equal to the sum of mass of products. Do you understand this? Okay. The sum of mass of all masses, the sum of masses. In fact, that is, you should not allow even a single vapor also. That too should be included. If it is in the gaseous form, that also included here. Okay. So that's what I want to mean here. Now, let me proceed. Let me cite an example for this. Let us work out a problem based on this. 6.3 gram. Take down 6.3 gram NaHCO3. What do you call it? Sodium hydrogen carbonate. Those days they used to call sodium bicarbonate also. So please make a note of it. So sodium hydrogen carbonate. Actually, this is rooted from carbonic acid. You know carbonic acid? H2CO3 is called carbonic acid. Something like sulfuric acid, you know. So here carbonic acid, right? So it is a dibasic acid. Why it is called dibasic acid? Because it has got two replaceable hydrogen. It can give out two protons, and that is why it's called dibasic acid. So H2CO3. So Na replaces one hydrogen so that you are able to get NaHCO3. When both hydrogens are replaced by sodium, it is called Na2CO3. So you should make the difference between these two. So what do you call this one? This is sodium carbonate. And what about this? Sodium hydrogen carbonate, right? Okay. Now, now we consider sodium bicarbonate, that is sodium hydrogen carbonate. That is added, that is added to 15.0 gram acetic acid solution, CH3COOH. What is this acetic acid? CH3COOH is an organic acid, acetic acid, and is also called ethanoic acid. Take down ethanoic acid. That is the IUPAC name. Okay. Now these two reactants react to form what, that is a residue is formed. They are not given any product here. Instead, they talk about the residue. A residue is formed. Residue is formed and leaving the carbon dioxide to air. So carbon dioxide is evolved as air. Okay. Now that residue was found to be 18 gram. Now we are interested to find out how much carbon dioxide would have been evolved. Do you understand this? Would have been released as air in this reaction. Okay, so this can be calculated based on law of conservation of mass. Okay, now let us write down the reaction. So we have to write down the balanced reaction. NaHCO3 that combines with CH3COOH. This is a weak is a kind of salt, and this is weak acid. Okay. Now sodium carbonate. Now listen to me. This sodium, listen, sodium, and in fact this H and OH. Okay. So this can form water. So you are able to get water plus and CH3COO Na. Okay. So CH3 COO Na and the residual carbon dioxide. I mean, this is the residue methyl acetate. Okay. So this is methyl acetate, this is water, and this is called the residue. And this is the gas. Now we are interested to find out the X, that is the amount of carbon dioxide released in air. Got it? Now the sum, what is the mass of this one? 6.3 gram. What about this? 15 gram. Okay. And what about the residue? That is 18 gram. And what about this? X gram. So simply by equating the sum of reactants and sum of product. So 6.3 plus 15 gives 18 plus x. So find out the value of x. 21.3 minus 18. Is it all? So how much? 3.3 gram. So the mass of carbon dioxide released. So you can report the mass of carbon dioxide released in atmosphere is equal to 3.3 gram. Okay. So this problem is solved based on the concept law of conservation of mass. You got this point? Right. Now let us talk about the law of definite proportion. Law of definite proportions. This was given by Joseph Proust in 1799. According to this law, a given compound always contain exactly the same proportion of elements by weight. Okay. This is also called the law of definite composition. You can either call it definite composition or definite proposition, proportion. For example, pure water. Okay. When you say pure water, that is obtained from various sources like you've got well, it can be obtained from river, it can be obtained from the sea or lake, etc. Okay. Or it can be from any country, India, US, Russia, anywhere. Okay. But all will have definitely how many atoms of hydrogen? Two hydrogen and one oxygen. But by mass, it has got that is hydrogen is to oxygen ratio is 1 is to 8 by mass. Do you understand this? Okay. Speak louder. That I'll explain because you have to take as an element. For example, hydrogen for two hydrogen. So actually this is H2O, right? For two hydrogen, it takes what is the atomic mass of oxygen? 16 oxygen, right? Okay. Yes. So what is the simplified ratio? One hydrogen, it should have 8 part of oxygen. I hope now you should be able to understand this. Okay. Right. Now, let us work out another example based on this laws of that is law of conservation of mass. Okay. Take down. Not conservation of mass. That is a definite proportion. So law of definite proportion problem. So when you consider the law of conservation of mass, where the reactions are involved. So here we go by the elemental percentage available in each compound. Okay. Now Copper oxide was prepared. Take down. Copper oxide was prepared by the following methods. So you can call it method 1, method 2, method 3. In the first method, we take 1.75 gram metal, that is copper, dissolved in nitric acid, HNO3. Okay, and igniting the residual copper nitrate. So you are able to get copper nitrate here, CuNO3. Now we are igniting, heating it, so that it yielded how much? 2.19 gram of, that is copper oxide. Got it? Now in the second method, 1.14 gram copper was taken, and that is dissolved in HNO3, the same nitric acid, and they were precipitated as copper hydroxide by adding caustic solution. That is, you are passing this through NaOH, caustic solution, so that you are able to get copper hydroxide, CuOH. Okay. From this, after washing, drying, and heating, washing, drying, heating, you are able to get 1.43 copper oxide, that is as salt, 1.43 gram. Now remember, in this method, by taking 1.75 gram, you are able to get 2.19 copper oxide, and in the second case, you are able to get 1.43. Okay, right. Now in the third case, we are taken 1.46 gram of copper once again, and that is strongly heated. It is strongly heated in air, in presence of air, oxygen. It directly gives 1.83 copper oxide, gram of copper oxide. Okay. Now, with this data, we must establish the law of definite proportion with respect to the copper oxide obtained from different routes. Do you understand this? Right. Now let us see step 1. In step 1, that is in reaction 1 and 2. Let us consider the first one. First case. What is the first case? That is 2.1 gram of copper was obtained. Is it not? Here. 2.19 gram of copper oxide obtained from where? From 1.79. So let us consider this as a percentage. Okay. So head down 2.19 gram copper oxide, that is CuO, obtained from, that contained, that is obtained from how much copper? 1.75 copper. Is it not? It should have come only from this copper. Got it? So 1 point, because we are taken only 1.75 gram, and here you are able to get copper oxide. So this one should have been obtained only from this copper. Okay, got it? Now I am making this as a percentage, right? So what could be 100 gram of copper oxide obtained from, that is equal to 1.75 into 100 divided by 2.19. Got it? Okay. So this is the weight of the original copper. I am taking this as a percentage of copper. Okay. Right? So that is equal to how much? Tell me. Please work out. 1.75 divided by 2.19 into 100. So, yeah, 79.9, right? So 79.91. So this much amount of copper in the first case. So this is case 1. Okay, right? So can you work out similarly for second case? Do it in the second case. So what is the copper weight? The copper weight is equal to how much? What was the weight of copper you had initially taken? 1.14 gram. So 1.14 obtained from that is 1.143 obtained from 1.14. So you can put 1.43 into 100. How much? Similarly, third case. What is that? That is this 1.43 should have been obtained from, 1.83 should have been obtained from 1.46. So it means in the second case, copper weight, that is 1.46 divided by 2 point, not 2 point, 1.83. 1.83. Okay. Now find out the ratio. What is the percentage? How much? This one. Then 1.14 divided by 1.43 into 100. Again 79.72. Okay, this is the the copper weight. And here 78 gram. So in almost in all these cases, you are able to get for 100 gram 79.7, 79.7, 79.7, almost equal. Whether it is obtained from different techniques, different methods, but the proportions are definite. And that is why it's called law of definite proportion. So the percentage of copper in copper oxide derived from all these three cases is nearly the same. How much? 79, 79.9, 79.9, 79.9. So it indicates that it is a verification for what? The law of definite proportion. Okay, got it? Now let us proceed with the law of multiple proportions. Okay, take down. Law of multiple proportions. That is the third law. Now, what is the law states here? It was proposed by Dalton in 1803. It states that if two elements can combine, if two elements can combine to form more than one compound, more than one compound, the masses, the masses of one element that combined with combined with a fixed mass, underline fixed mass of other element. And these two are in the ratio of small whole number. It may be a little bit confusing, but let me explain. So once I am able to illustrate with a particular example, you should be able to understand this concept or law. Let me say hydrogen that combines with oxygen to form what? Water. Is that not? How many gram? 2 gram. And here 16 gram. So that you are able to get 18 grams. Got it? Okay. Now I'm taking another compound. What is that compound? Hydrogen peroxide. Peroxide. So here the same hydrogen and the oxygen, okay? But the ratios are different. For example, here 2 gram and here 32 gram. Now it results 34 gram of hydrogen peroxide. So in this case, this is hydrogen, this is oxygen, and you are able to get H2O. Whereas here hydrogen, oxygen, you are able to get H2O2. Okay. So the mass of oxygen, that is here 16 gram and here 32 gram, that combined with the fixed number of 2 grams of hydrogen. Is it not? In both the cases, they are 2 grams. Okay. But they, they have a simple ratio. In this case, 16 is to how much? 32. The ratio of this oxygen. This is 16, this is 32. Okay. So here 2 gram is combining with the 16 gram. 2 grams of hydrogen is combining with 32 gram. So the ratio is 16 is to 32. Okay. So this is what he wanted to explain. Okay. So it is because of this ratio you are able to get different compounds. Are able to follow? So when the same oxygen combined with the hydrogen in the ratio 2 is to 16, okay, but here it forms water, but in this case it gives hydrogen peroxide because it is doubly added to hydrogen. Is it not? Okay, right. And based on that, let us try to illustrate. Okay, take down the problem based on Dalton's, what is that law? Law of, what do you call it? Yes. So what are the three laws we discussed? First one is law of conservation. Second one is law of definite proportion. Third one is law of multiple proportion. Now this is a problem based on law of multiple proportion. Okay, right. Write down law of multiple proportion. Law question. Take down three oxides of nitrogen. Three oxides of nitrogen contained 63.6%, 46.7%, 30.4% nitrogen. So three oxides contain different percentage of nitrogen, as in the case of oxygen in water and hydrogen peroxide, right? In this case, it contains 16 gram in the case of water, whereas here it is 32 gram in the case of hydrogen peroxide. Similarly, you've got some nitrogen and you've got different types of oxides, and these oxides contain different percentage of nitrogen, and that is why they are giving different oxides of nitrogen, right? Okay. Now, with this, we need to illustrate the law of multiple proportion. Let us go one by one. The first case, case one, take down. So the oxide of nitrogen contains how much? The first case, let me put NX, otherwise let us put that is nitrogen oxide. Oxide, the first case, nitrogen oxide. Okay. So this nitrogen oxide contains 63.6%. And what could be the remaining part here? Oxygen, nitrogen, oxygen. What is that? If it is 63.6, it should be 100 minus 63.6. Is it not? So that is equal to how much? 36.4 gram, right? So 63.6 contains, combines with the 36.4. Got this? Okay. So this is the first case. So the oxygen is 36.4. Now we know very well 1 gram contain, can react with how much? So 63.6 can react with 36.4 oxygen. Therefore, 1 gram of nitrogen can react with how much gram of oxygen? So 36.4 divided by 63.6. Got it? Into 1. So it means how much? 36.4 divided by 63.6. How much? Point? Yes. So 0.572. So you can make it as 0.57. Okay. Now case 2. Similarly, in the second case, what is the nitrogen? 1 gram nitrogen reacts in the second case. How much? The difference. First, you have to find out the oxygen percentage. So oxygen is equal to 100 minus 46.7. So how much? 53.3. So 53.3. So how to do? So 1 gram nitrogen reacts with the oxygen. How much? That is 3.3. Yeah. That is 46.7 divided by 53.3. Okay, take down. I'm sorry, 53 point. You have to make ulta. 53.3 divided by 46.7. How much? The oxygen is 1.14. Correct. And similarly, can you put the third one? Third, third case, 100 minus 30.4. How much? 69.6. So 69.6 is formed by 30.4, reacting with 30.4 nitrogen into 1 means how much? 2.26 gram of oxygen. To 8, you can take it at 2.26. So this one is the third ratio. Are you able to follow? So in all these cases, now listen to me. Let us make it as a simplified ratio. What is the first ratio? 0.57. I am talking about oxygen ratio in both all the three compounds. So how much? 0.57. 0.57. In the second case, 1.14. In the third case, 2.28 or 26 or 28? 28. Okay. So in the third case, it is 2.28. Okay. Now, what is the simplified ratio? The simple ratio rate is 57. So let us divide by this. So divided by 0.57, 0.57, 0.57. Okay. Now this becomes 1 is to, what about this 2 is to, what about this 4? Got it? So the ratio is 1 is to 2 is to 4. That clearly indicates they have the multiple proportions, and that is why it's called law of multiple proportions. So do you understand this? So this establishes the law of multiple proportions. Okay, and we have yeah. So this one. So this is talking about the law of multiple proportions, whereas in the case of the law of definite proportion, you have the same ratio, 79.72, 79.7. Okay, whereas here they have different ratios, multiple ratios. Are you able to follow? And that is why we convert this as a whole number. Okay, got it? Right. And the fourth one is the law of reciprocal proportion. Take out. Fourth law, law of reciprocal proportions. In this case, actually, this law was given by Richter in 1792. He stated the law of masses of two elements, the law of masses of, the ratio of masses of two elements. Take the ratio of masses of two elements, A and B. Let us consider mass A, element A, element B. They combine separately with a fixed mass of the third element. So these two combine with a fixed mass of third element. Okay, C. Either in the same, either in the same or or simple multiple ratio. Simple multiple of ratio of masses in which A and B directly combine with each other. Okay. Now let me explain with some examples so that you can understand the law of reciprocal proportion. Let me repeat once again. So what is law of reciprocal proportion? The ratio of masses of two elements. Let me consider A and B, and their masses, they are combined. Okay. And they further combined with the another element C, right? Is either in the same ratio or in different simple multiple ratio. Okay. So the ratio of the resulting mass in which A and B combine directly with each other. So let us illustrate this with an example. Law of reciprocal proportion, LO or P. Example. Take down the element hydrogen and oxygen. They combine separately with the third element, sulfur, to form H2S and SO2. respectively. Then show that they combine directly with each other. They can combine directly with each other to form H2O. Okay, do you understand? Let me put some schematic diagram so that it should be useful to explain you. So here, let me put sulfur here, and we have got the two elements A and B. In this case, hydrogen and oxygen, right? Okay, draw this. Now these two can combine to form what? H2S. Okay, got it? These two can combine to form sulfur dioxide. Okay, and among themselves, A and B, okay, they can form a compound in a particular fashion also. Now we have to prove that. We have to justify this statement. Okay, so definitely, these two should form water, is it no? Okay, now listen. Now let us go one by one. The law of reciprocal proportion, and this is the best illustration. Now listen. In this, we have what is the ratio of hydrogen to sulfur based on atomic ratio? Tell me. Here it is. This atomic weight is how much? This is 32. This is 1. This is 16. Right? So H2 means 2 is to 32 ratio. Got it? Okay? Done? And what about this hydrogen and oxygen? H2 is to oxygen. So 2 is to how much? 16. Right? Okay? And what about these two? Sulfur dioxide. So 2 is to 16 once again. Is it no? 16 is to, you can put 16. So sulfur dioxide. Is it not? So 32 is to what? 16. SO2. 32. Correct. SO2. Is it not? So 32. Okay. Now, you see, these ratios are related in such a way that this is 1 and this is 16. Is it not? For example, 1 is to, let us simplify this, 1 is to 8, right? What about this 16 and this is O2 means 32, so 1 is to 1 here, okay, right? And what about this here 2 is to 32 means 1 is to 16, right? So the ratio or related here, that is a 1 is to 16 and here 1 is to 8. Are you able to follow? So these ratio are related in such a way that is 1 is to 16 is to 1 is to 1 by 16 is to 1 by 8. So that is nothing but it is a reciprocal. You can multiply by 2 so that it becomes what? 1 is to 2, right? So they are simple multiple of each other, is it not? So likewise we can establish. But you have to convert this as what? Yeah, whole number ratio. Okay. So for this ratio, how you have to do? You have to multiply by 2. Okay, multiply by 16. So 1 by 16 into 16 is to 1 by 8 into 16. So it makes 2. I mean 1 is to 2. Okay. Got it? So in the next class, I will be discussing about Gay-Lussac's law and Avogadro's law. Okay? So all these concepts discussed today are very, very important, and you've got a lot of problems based on these concepts. So please go through all the concepts thoroughly and work out as many problems as possible. I will also give the worksheet based on this. Okay, right. So